Hi, this instructional video is sort of a prelude to the next instructional video, which is about factoring polynomials. But in order to learn about factoring, we have to learn about distributive property. You see, because when you apply the distributive property, that is the inverse operation of factoring. It's like going backwards and forwards. So to learn about factoring, we have to know how to do the distributive property. Let me just show you how that works, distributive property, using number one. We have a binomial. Let's suppose x plus 1, those two terms are the flight attendants. And let's suppose the second binomial, x plus 2, are the passengers. So the first flight attendant is going to service the first passenger. X times x. That's x squared. And then the flight attendant is going to service the second passenger. X times positive 2. That's plus 2x. Okay, now the first flight attendant takes a break, and the second flight attendant services the same passengers. So 1 times x is 1x. And 1 times the second passenger, which is 2, which is positive 2 or plus 2. And anytime you apply the distributive property, many a times you'll end up combining the like terms in the middle. In this case, 2x and 1x, they add up to be, since they're both positive, 3x. And since the first and the last term we haven't done anything to it, we just put it down and we end up with a binomial. 3-term polynomial, that is. That's called distributive property. Why don't you try numbers 2 and 3 on your own? Okay. Now, distributive property of two binomials, sometimes we call that the FOIL method. FOIL. F-O-I-L. F mean the first terms of the two binomials, because x times x is x squared. O means the outside terms. If this is the bus, this is the window seat, this is the window seat. They're the outsides. So x times 4 is 4x. And of course, if there's an outside, there must be an inside. So these are the aisle seats. Negative 2 times x is negative 2x. And L represents last terms of the two binomials. So negative 2 times positive 4 is negative 8. And anytime you apply a FOIL method, you have to combine the middle terms together. So you end up getting x squared, 4x minus 2x is plus 2x minus the 8. And that is the polynomial you end up with when you do the FOIL method. And the third one, same thing. X times x, x squared. X times 7, 7x. 3 times x, 3x. 3 times positive 7, plus 21. Combine the middle terms. 7x and 3x become 10x. These first and the last terms I haven't done anything to. Just copy it down, and there's your polynomial. 3-term polynomial. Now we can talk about factoring. Now that we talked about distributive property, or using the FOIL method to multiply two binomials, we have to go backwards now of distributive property, which is called factoring. Okay? Remember the little note I wrote over here? Distributive property, the inverse operation is factoring. Okay? So, we have here number one, x squared plus 3x plus 2. And here's how it works. When you factor, you know this is the product of two binomials. A binomial times another binomial gave us the polynomial. So we have to go back and put it back into the binomial format. So how does this work? Well, we're going to use a thing called AC factor method. AC. If this is a standard form, ax squared plus bx plus c, we're just going to worry about a and the c. And that will help us get the b in the middle. Let me explain. The question is, what times what would give you x squared, the a term? And you're going to say, well, that's going to be x times x. And we're going to put them into the parentheses form already. Second question is, what times what could possibly give you 2? And you're going to say, that's going to be 1 times 2. And here's the question. Well, what must their signs be that if you took the two factors 1 and 2 and added them or combined them would give you a positive 3? You have to say, well, 1 has to be plus and 2 has to be plus. Because 1 times 2 is 2, and 1 and 2 both positive gives you 3 if you add them. And this is the proper factorization for that polynomial. How do you check if it's right? Do the distributive property again. X times x is x squared. X times the second term is 2x. Now 1 says, me too, me too. So 1 times x is 1x. And 1 times 2 is 2. I said in the last segment, anytime you do a distributive property, you combine the middle terms, you end up with x squared plus 3x plus 2. There it is, the original. So this, in fact, is the correct factorization. Ta-da! You try these two now. Okay, so you said, well, what times what is x squared? Is x and x. Now here's a tricky part. What times what could give you an 8? Then you have to list them. Well, it could be 1 and 8, or it could be 2 and 4. There's no other factors that become 8 if you multiply. And now the question is, which one of these two pairs, if you were to combine them, either add them or subtract them, could possibly give you a positive 2? Then you'll say, well, 1 and 8 could be either become 9 or 7 if you add or subtract. But 2 and 4, if you subtract them, it'll become a 2. And the question is, what must their signs be? Well, to get a positive 2, the bigger number has to be plus, and the small number has to be negative. And that's it. And if you want to check your work, do the FOIL method again, and you'll get the same trinomial. And the third one? Here we go again. 2 parentheses. What times what is x squared? You said x and x. What times what is 21? You listed as 1 and 21, and 3 and 7. And I think that's it. And the question is, which one of those pairs, if you were to combine them, add or subtract, would give you a 10? Then you said, well, 3 and 7, if you add them, becomes 10, and they both have to be plus. Because 3 times 7 is 21, and 3 and 7 added together becomes 10, and that is the correct factorization. There it is.